Every element in the periodic table, from hydrogen to iron to gold, is made of the same thing: trefoil knots in the membrane. The question is not what the ingredients are. The question is how they are arranged. Hydrogen is the simplest case, a single trefoil knot with one binding site available. If the binding site is occupied by a trapped ripple, we call it a hydrogen atom. If it is empty, we call it a proton or a neutron, depending on context. In wave physics, those are the same object in different conditions. Every other element is built from hydrogen. Every atom of every element is a specific arrangement of trefoil knots, braided and fused together under conditions of extreme energy. The only place in the universe where that energy is routinely available is inside a star. In a stellar interior, knots are driven together by enormous tension gradients in the membrane. The collisions happen at random angles and with enormous force. Most combinations are unstable and come apart immediately, but certain arrangements hold. The membrane settles into a configuration of lower total tension, and that configuration persists. What we observe as the periodic table is the catalog of arrangements that survived. 2 knots fused laterally produce deuterium, a 2-knot structure with 1 active binding site. 3 knots produce tritium, which is metastable and eventually sheds a ripple and reorganizes. 4 knots, fused in a tight symmetric arrangement, produce helium-4, completely inert, with no exposed binding sites at all. The pattern continues up through every element. The number of knots determines the mass. The geometry of the arrangement determines how many binding sites remain exposed. And the number of exposed binding sites is what chemists call valency, the capacity of an atom to form bonds with other atoms. Carbon has 4 exposed binding sites. That is why it bonds with 4 hydrogen atoms to form methane, and why it can form the long chains and rings that make organic chemistry possible. Oxygen has 2. Nitrogen has 3. The noble gases, helium, neon, argon, have none at all. Every binding site is sealed by the geometry of the arrangement. There is no place available to form a bond, and so they do not. The periodic table's familiar repeating structure, rows of 2, 8, 8, 18, 18, 32, 32, emerges from the geometry of how knots pack together in expanding concentric rings. The row lengths are not arbitrary. They are the natural result of fitting the most stable arrangements of chiral knots into a 2-dimensional surface. There is one more thing worth noting. The same knot count can sometimes produce more than one stable arrangement. Iron 56, for example, has 56 knots, and there are multiple configurations of 56 knots that are stable. This is exactly what we would expect from random fusion activity in a stellar environment. Not every collision produces the same result, and multiple stable outcomes are possible from the same starting material. The existence of multiple elements with the same mass number is a natural consequence of the process, rather than something requiring a separate explanation. In the next video, we will discuss magnetism,